Unit 7, Target 6. I can identify prime numbers and find the prime factorization of numbers through 1000. A prime number is a whole number greater than 1 whose only factors are 1 in itself. Examples of a prime number would be 2, 3, 5, 7, and so on. A composite number, the opposite of a prime, is a whole number that has more than 2 whole number factors. Examples: 4. It has the factors 1, 4, and 2. Example: 6 has the factors 1, 6, 2, and 3. 8 is another composite number. 1, 2, 4, and 8 are all factors, and 9, 1, 3, and 9. So when we're trying to determine if a number is prime or composite, we need to look at what factors does it have. Does it have 2 factors, which makes it prime, or more than 2, which makes it a composite number? So if we look here, tell if the following are prime or composite numbers. When I'm thinking of 13, I only have one multiplication problem, 1 times 13, that we can do to get 13. So 13 will be a prime number. When I'm looking at 24, I know that I can have 1 times 24, but I can also have 2 times 12, 3 times 8, or 4 times 6. So we have a lot more factors of 24, which is going to make it a composite number. Okay, when I look at 27, I know I have 1 times 27, but in this case I also have 3 times 9, making this have more than 2 factors and also making a composite number. When I'm looking at 31, I'm looking for all the factors. I know that 1 times 31 will go into it, but when I look at others, 2 won't, 3 won't, 4 won't, 5 won't, and if I keep working through the numbers, no other numbers will go evenly into 31, so that makes 31, a prime number. The other part of this is that we need to be able to show prime factorization. When we show prime factorization, we are going to use the expression of a composite number as a product of its prime factors. So when I want to show the prime factorization for 45, I am going to break it down to show it as a multiplication problem of its prime factors. When I start with this, I can start with 45. I know it's a composite number. I'm going to break it down. You can break it down however you want. There's different ways. In this case, I'm going to break this down into 9 times 5, because 9 times 5 is 45. Now I look at these numbers. 9 is still a composite number, so I can still break 9 down. It would be 3 times 3. 5 is a prime number, so we can bring it down. Now we have 3, which is prime, 3, which is prime, and 5 is prime. So we have the prime factorization for 45. Sometimes you'll be asked to write this using exponents. If I do that, I think about what I did earlier in this unit, and I have 2 of them, so I'm going to have 3 squared times 5. Now let's break 64 down. As I said earlier, there's actually more than one way to do this. I could start with 2 and 32. I could go with 8 times 8. You're going to end up with the same thing for your prime factorization no matter where you start. I'm going to start with 8 times 8. 8 is still a composite number, so I'll break it down into 2 times 4. This 8 can also be broken down into 2 times 4. Now, 2 is a prime number, but 4 is a composite number, so I still have to break it down. 2 is prime, and 4 can be broken down into 2 times 2. And now I have all prime numbers across here, so I'm going to write this using exponents. This will be 2 to the 1, 2, 3, 4, 5, 6, so to the 6th power.